Yes, shall we start?
Yes, sir.
Okay. See, yesterday we have started the electrical system, and just again we can go through the electrical system and then move on to the force voltage, force current analysis. So the electrical system composed of only the three elements: resistance, capacitance, and inductance. So resistance, which expresses the characteristics of dash part resistance. So resistance will express the characteristics of dash part, and inductance will be express the characteristics of mass, and the last one, the capacitance, which express the characteristics of spring. So this is for force voltage analogy and force current analogy. You see that the current and voltage relationship, as already informed yesterday, the relationship is reciprocal. So for inductance, the voltage is L into di by dt. So for the current relation with the capacitance, that is I of t is equal to C into dV by dt. So based on this, your mass as well as the spring, the relation will be differ. The dash part is same for both the voltage relation as well as current relation. So the dash part is same. The resistance expresses the characteristics of the dash part, but the inductance that represents the mass in voltage case, and for capacitance it represents the spring. So you see that for the current, in case of the relation to the current, the mass and the spring is exactly reciprocal for voltage and current. So this is the only difference we have to point out there. You have to remember this. So already we have discussed yesterday this problem, how to solve this problem, applying the transfer function of the electrical network. So you first look out what is the input of the network, what is the output of the network, then find out the transfer function. So sometimes the problem like this, you have to find out transfer function. Sometimes in certain problems, they will specify what is your output of the network, what is the input of the network. So this is the case of one source. You see that the sources, there is only one source. Suppose in the sources, there are two sources like in superposition theorem, they will specify what is the output of the network, what is the input of the network. You have to find out that ratio, that transfer function only. So that is the case of transfer function of the electrical network. So yesterday I circulated some supporting PPT in your group. So because last semester I handled the first year BEEE, Basic Electrical Electronics Engineering. So that I just share my slides to remember what are the network theorems, how to practice the superposition, Thevenin's theorem, Norton's theorem, how to apply the KCL, KVL. So for that only I circulated the PowerPoint slides, so that it will be easy for the coming section. Okay, so we have solved this problem and we directly enter into the electrical analogy of the mechanical translation system. So from this onwards, your main core part is starting. So already discussed what is in the electrical analogy means a mechanical translational or a mechanical rotational system will be given. You have to draw the equivalent electrical circuit diagram for the mechanical system. Suppose the mechanical translation system is given, you have to draw the equivalent electrical circuit diagram. So we know that the three elements, so mass, spring, and the dash part is given. So equivalently, there are three elements in electrical system: resistance, capacitance, and inductance. So the for the force voltage analogy means the force balance equation converted into voltage balance equation. Force balance equation converted into current balance equation. It is called as force voltage, force current. So because why we are having the two cases means in mechanical system force is the input, but here you can use both voltage source as the input as well as the current source also can be act as an input. So that's why we have the two cases: force voltage analogy, force current analogy. So first for force voltage analogy, dash part represents, it is represented by resistant element, mass is represented by inductance, and spring is represented by capacitance. So for force current analogy, the dash part is common, but the mass and the spring is reciprocal, that is inverse compared to the force voltage analogy. So with this introduction, we are moving to the problem. So I hope you go through the guidelines. Yesterday we already discussed how to calculate the number of nodes. The number of nodes equal to the number of meshes in the electrical systems. So then we go through that for each element in the mechanical system, what is the equivalent in electrical system. So mechanical system dash part is represented by resistance, for mass it is represented by inductance, and spring is represented by capacitance. So now I hope that you have solved this problem yesterday itself. So already we are out of time. Okay, so for M1 and M2, I hope you have drawn the force balance. That is a diagram for M1 and M2, and you have derived the differential equation for M1 and M2. and we have applied the Laplace transform also. So up to this we have finished for M1 free body diagram, and we have noted down what is the applied force, what are the opposing forces. So up to this I hope we have finished yesterday. So up to M2, M1 and M2, we have drawn the free body diagram and we have derived the differential equation for the each applied force and opposing force. Then you framed the two equations, one equation for M1 and one equation for M2. So now are you getting this equation, equation 1 for M1? Is there is any doubt or clarification for M1? Is there is any mistake in the slide, or you are getting a different answer from this? So first of all, please clarify whether you are getting the right equations for M1 and M2 free body diagram. From the free body diagram, you are getting the correct differential equation for M1 and M2. So all of you are getting this equation, equation 1 and equation 2 for M1 and M2. So any doubt on this? M1 and M2. So the mechanical translation system, whether you are getting this equation, differential equation. Yes, I need anyone reply. Whether you got the same differential equation for M1 and M2.
Sir, M2 once show, sir.
M2. Whether you are getting this equation from the free body diagram. Utilize the session properly. If you have any doubt, please tell me, or if you want to discuss, you can discuss here. So I hope you already worked out the problem in your home. If you missed
Sir,
that,
for spring K1 and dashpot B1 to like how the direction we have to give.
see, first for M1, you see the diagram first from M1. So what are all the connecting elements? So first one is K is a connecting element. Then B12, second one, and third one is B1, and the input force is F of t. Okay, so there are four things: K1, B12, B1, and F of t is applied force. And see, this is the displacement x1 and v1 also given. So what? How many number of there? So 1, 2, 3, 4. There are 5 elements connected with M1, that is related with M1. So first one F. F is applied force. Actually, this arrow mark should be in opposite direction. Accept that. And the remaining 4 are given. Remaining 4, that is M1 represents a mass 1. That is M1. This M1 represents as Fm1. So next B1. So this B1 is given here. B1. So FB1 and B12, that is B12 is here. That is relating M1 and M2. And the last one is FK1. That is FK1 is connecting between the M1 and M2. So now for each forces, you are deriving the differential equation. So in this, you want to know that how to determine the direction. So if you are considering the M1, it will be starts from X1 to X2. That is for dash part also, it will be starts from X1 to X2. Suppose if you are considering the M2 side, it will be X2 minus X1, and for dash part X2 minus X1, d by dt into X2 minus X1. So which is the starting point? We are seeing or looking from M1. So you have to start from X1 to X2. And the same dash part also B1 to d by dt into X1 to X2. If you are seeing the free body diagram from M2, you have to start from X2 to X1. So the same thing for dash part d by dt into X2 minus X1. So whether you are getting this equation number 1. Then I want the next slide. So I verified that you are getting this equation 1.
Yes, sir.
Okay. See equation 2, free body diagram. See, at least please respond, man. Anyone, please respond, right? See, don't be silent. It is a recording meeting. I will submit this recording meeting to uh, uh, that is my senior officials. Later, you don't blame me, and I also don't blame you because everything is a recording. If you all are keep silent, means it is very very useless, right? Because of we are having the different classes, different meetings. So some other classes we have the frequent interaction because our senior students are responding very fast. Even that subject is very complicated than your control system. And taking non-linear system is very very complicated. So I need frequent interaction. If you are thinking others will reply, let us wait me means it is not a loss for me. It is my duty. I will take the class because even if I am talking here, everything is recording. So kindly be a uh, interactive. So don't think that others will reply. We will wait for them. Why we have to reply? Don't consider like that. It is a volunteer thing. Okay. So whether you are getting the equation 2 or not,
Sir, for K1 and B12, like the direction will be how the force direction.
the force direction. Now we are looking from the M2 side. That is mass 2 side. So first of all, you are clear with the free body diagram.
No, sir, the
So
direction of B12 and K, how the direction is
so
towards M.
so
Because K1 and K2 are direction, no, sir.
okay,
So
okay.
they
I'll first clear this. So so now we are considering the M2 side. So now we are considering from the M2 side. So M2 side, what are all the connecting elements? First one is K2, then B2. So these are all only connected to M2 side. K2 and B2 is only for M2 side. And see that again, K1 is common between M1 and M2. B12 is common between M1 and M2. So in addition to that, displacement X2 and V2. Okay. So two elements are individually, that is unique for M2. K2 and B2 is only for M2, and K1 and B12 is common between M1 and M2. So you have the four elements plus X2 and V2. So for M2, you look at this, all the forces are represented on R. So you have to find out whether all the forces, Fm2 is represented. So Fm2, next K2, B2, next K2. So K2 also represented. K2 also represented. So next one is B2. So B2 also represented. Next B12 K1. So B12 K1. So all the forces are indicated in the free body diagram. So now first you have to start from the Fm2. So this Fm2 is here. Fm2 is equal to d square x2 by dt square because the displacement is given x2. So next B2. So for the second force is Fb2. B2 into dx2 by dt. And the third one is K2 into x2. So you see the diagram, the K2 is only for M2. It is not a common between M1 and M2. So we are writing K2 and X2. But you see that K1 and B12 is common between M1 and M2. So again, I informed you, you have to start from M2 side to M1 side. So therefore, B12 d by dt into X2 minus X1 plus K1 into X2 minus X1. That is a displacement in the M2 side minus the displacement to M1 side. So you are clear in this, how to draft this, how to derive this differential equation 2. While you are considering an M1 side, look from M1 to M2. While you are drawing the free body diagram for M2, starts from M2 to M1. So look out which are all the common elements between M1 and M2, which are all the elements unique to mass. So based on that, write the differential equation for each element and add the applied force equivalent to opposing force. Here, no applied force, therefore 0 equivalent to the remaining opposing force differential equations, summation of the opposing force equations. So next, after deriving this equation, next you have to substitute for electrical system. Now we have to derive the electrical analog. So for that, already I told you, if you take the double derivative of the displacement, that is called as the first derivative of the velocity. So therefore, d square x by dt square equivalent to dv by dt. And the first derivative of the displacement equivalent to velocity. And again, the displacement is given by integral of v of dt. So Y means in electrical system, in current and velocity, we have to talk about the velocity. In electrical, that is voltage and current in terms of velocity. But in mechanical system, we are discussing about the displacement. So this displacement should be mapped to the velocity in electrical system in terms of voltage and current. So in mechanical system, only displacement and force. In electrical system, voltage and current. So another one is velocity. You have to map this force balance equation into the velocity with respect to the voltage and current. Why? The flow of electrons is called as current. A force is required. A force is required to move the electron. So therefore, you have to map this force into the velocity and electrical system. Therefore, we are taking the double derivative of displacement is given as the first derivative of velocity, and the first derivative of the displacement is given as the velocity. And if you take the displacement, x is equal to integral of v of dt. Now substitute this double derivative and the single derivative, the first order derivative, to be substituted in equation 1 and 2, and you will get the equation 3 and 4. So the first one, d square x by dt square. So if you take the first equation, the d square x by dt square is substituted as dv by dt. So d square x by dt square equal to dv by dt, which is given as m1 dv1 by dt. So please understand that from this section onwards, we are entering into the electrical system. So you have to substitute the double derivative for the displacement with respect to the velocity concept in electrical system. So substitute that value and you are getting the equation 3 and 4. So yeah, any doubt in this equation 3 and 4? Why we are converting this velocity and equivalent to the displacement? How we are entering the value? How we are getting the equation 3 and 4? So I look at this. Substitute the d square x by dt square equal to dv by dt. Dx by dt equal to v, and x is equal to integral of v of dt. So substitute this value in the equation 1 and 2. You will get the equation 3 and 4, and these 3 and 4 equation representing the equivalent electrical system equation. After substituting this equation, you are getting the electrical equivalent differential equation for the mechanical translation system. Have a note on this equation, equation 3 and 4. Equation 3 and 4.
Yes, sir.
So have a note on this equation. I have written this equation 3 and 4. So I move on to the next step.
Yes, sir.
Okay. See, now we are entering into the force voltage analogous circuit. So just it's a recall: mass, spring, and damper. You are having the mechanical translation system diagram, 3 elements. The equivalent diagram, equivalent element representation in electrical system is resistance, capacitance, and inductance. So dash part equivalent is resistance, and the mass is equivalent is inductance, and the spring is equivalent is capacitance. So this is for force voltage analogy. For the mass and the spring is reversed for force current analogy, because you know that the voltage and current relationship with the inductance and capacitance is reciprocal. That is, voltage and current is reciprocal with the inductance and capacitance. So keep this in mind. We are moving to the diagram converting directly into electrical system. So I hope you understand this slide. If you have any doubt in this slide, please ask me. The first one, electrical analogous element for the mechanical system, is given below. So the first one, what is f of t? The f of t is a force, that is input force. So this f of t is input force. What is the equivalent in electrical system? E of t. So that's only I informed. The flow of electrons is called as current. A force required, that's only you have studied in physics, electromotive force, EMF. A force required to move the electron, that is called as voltage. So the f of t concept is mechanical translation system. Input is force. So in electrical system, what is the input? Voltage. E of t is the input. Now we are discussing force voltage analogy. In force current analogy, E of t will be replaced by I of t. Okay. So first one is f of t input. E of t is the input in electrical system. So next, V1 and V2. So this V1 and V2, which represents the velocity, and the equivalent is I1 and I2, that is current 1 and current 2. Since we have the two loops, there are two loops. Why? There are two nodes in the mechanical system. M1 and M2 are the nodes in the mechanical system. While converting the equivalent circuit for electrical system, we are having the two loops. So that's why we have the two currents I1 and I2. So how many number of nodes in the mechanical system? equivalently number of loops in the electrical system. So this is the general guidance principle. That is a principle to draw the diagram. So you have to find out how many number of mass elements. If there are two mass elements, means two nodes. The same thing, you have the two loops in the electrical system. So next M1, which is represented by mass, is the equivalent represented by L1, and M2 is represented by L2. Next, you know that the B1 is represented by R1, B2 represented by R2, and B12 is a common between M1 and M2. Therefore, we are giving the name R suffix 12. So next one, K1 and K2. So you know why you are putting 1 by C1 and 1 by C2. Okay. So usually the capacitance, if you take the series or parallel capacitance, how will we calculate? 1 by C equal to 1 by C1 plus 1 by C2 up to the infinity. So the same thing, K1 and K2 spring is represented by 1 by C1 and K2 spring is represented by 1 by C2. So now coming to the diagram, you see very carefully because this is the only problem we are discussing. Later will be a practice problem. So first one, E of t. So first one, E of t. So what is the E of t? Is the input of the electrical system. So there F of t, there is only one input, F of t. For M2, applied force is 0. So for the electrical system, the same thing, only one input. Therefore, we are connecting the only one source, E of t. Okay. So next, how we are getting L1 and R1? So L1 represents the mass and R1 represents the dash part. Both the elements are connected in series. Okay. So how we are getting L1 and R1? So how we are getting the L1 and R1? You listen, L1 and R1 are connected in series. You go to the mechanical system. So L1 represents the M1 and the dash part represents the B1. So L1 represents the M1 and the dash part B1 represents the R1. So these two elements are connected in series, L1 and R1. So, and next one, how we are getting the R12 and C1? R12, that is B12 is a common element. B12 is a common element between M1 and M2, and K1 also a common element between M1 and M2. Therefore, K1 represents the capacitance, B12 represents the resistance. You have to connect the two elements common between M1 and M2. That is, these two elements should be common between two loops. So that's why you see that R12 and C1 are connected as a common between first loop and second loop. So I think these four elements are clear. Next, how we are getting L2 and R2? So M2 represents the L2 and B2 represents the R2. So L2 represents the M2 and R2 represents the B2. And last one, C2. C2, you are having the K2 spring, therefore K2 is represented by P2. So what is the I1 and I2? Because we are having the two velocity, therefore V1 and V2, we are indicating as a I1 and I2. So please ask me if there is any doubt in this circuit, how we are converting the mechanical system, mechanical translational system into electrical system. So the number of elements in the mechanical system should be tallied with the number of elements in the electrical system. This is the first condition. Number of mechanical elements, dash part, spring, mass. How many number of elements in the mechanical system should be tallied with the number of resistance, capacitance, inductance, number of elements in the electrical circuit. This should be tally. Second one, number of nodes. Number of nodes, there are two nodes, M1 and M2 means there should be two loops. If there is only one node, there is only one loop. If there are three nodes, you have to draw the three loops. Okay, this is the second condition. Third one, what are all the elements common between M1 and M2? Here R12 is common, C1 is common. So therefore R12 and C1 is common between first loop and second loop. At last, indicate the direction of the current. Don't forget that it represents a velocity. There are two currents, two flow of currents, I1 and I2. We have to specify the flow of current. So, you have any doubt in this? How we are converting the resistance, capacitance, inductance from mechanical translation system? So this is force voltage analog circuit. So any doubt in this? Shall we move on to the next slide? How to apply the Kirchhoff law to derive the equations? So, any doubt?
No, sir.
Okay. So, remember the circuit. Now we are applying the Kirchhoff law to derive the equations. So, the first equation, which is the first diagram, which represents for M1 node, and the second diagram, which represents for M2 node, we have to derive the electrical equation by applying the Kirchhoff law. So, the first one, you see that for M1 node, there is the input. For second one, M2, the input is 0. So you have to write the Messi equation. That's only yesterday I circulated the PPT. How to write the Messi equation for the given diagram. I hope you are having the PPT. That is how to derive the Messi equation. So first one you see for equation 1. So input is E of t. Input is E of t. This input E of t is how it is split up. So first one is L1 into di1 of dt, and the current flowing through the resistor, which is given by the voltage drop across the resistor, is I1 into R1. So next one R12, that is there are two currents are flowing because R12 is a common element, therefore I1 minus I2. Okay, the same case how we are approaching for M1. So R12, the current will be I1 minus I2. So next for capacitance, 1 by C1 integral of I1 minus I2 into dt. So this is the electrical equations by applying the Kirchhoff voltage law for the M1 node. That is the first node. Next one for the second node. So here the input is, there is no input. Input is 0. Therefore, the input is 0. So therefore, the input is 0. Same as the case of M2 node. So first one, you start from the L2. L2 into the current flowing is I2 current. That is the second current I2 into di2 by dt. So next one R2 into I2. And then this capacitance T2. So these are all the individual elements for M2. So after that, you have to write the equation for R12, which is a common element between M1 and M2, and this capacitance C1 also common. Therefore, R12 equal to R12 into I2 minus I1. Here the current direction should be I2 minus I1 for the second mesh. Then 1 by C1 into integral of I2 minus I1 into dt equal to 0. So these two equations called as a Messi equation, which is exactly equivalent to the differential equation in equation 3 and 4. So based on the exam point of view, even if it's a MCQ question, we will give the circuit diagram. You have to write the Messi equation for the circuit diagram. Okay, even it's MCQ. So
Sir,
we will give, yes.
Sir, in loop 2, when we are moving from inductor and coming to C1, then like at inductor, there will be drop in voltage, no, sir?
Yes, that's only given L2 into di2 by dt.
Minus L2 will know, sir, it will be.
See, we are assuming from M2 side.
Yes,
See,
sir.
actually how will you do the circuit theory, man? You have to find out which is the input source. This input source is what are all the voltage drop across the each element in the circuit, right? See, right or wrong? See, input is voltage source. This input voltage source equivalent to voltage drop across the each element in the circuit. That is applying voltage is E of t. The second circuit applied voltage is, there is no applied voltage, 0. This 0 voltage equivalent to summation of voltage drop across the each element.
Okay.
Hey, whether you understand or not, circuit theory, applied
Yes,
voltage equivalent to voltage drop across the each element in the circuit diagram. That is summation of the voltage drop across resistance, capacitance, and inductance. How many number of elements you are having?
yes,
B
sir.
equivalent to I into R. B equivalent to I into R. B is the applied voltage. I is the current flowing in the circuit. If there is only R, resistance means I into R. If there is a capacitance means that is 1 by C into integral I2 minus I1 or I1 minus I2. If there is an inductance means it will be L into di by dt. So voltage drop across the each electrical element summation. That is the output side. Now you check that whether it is right or wrong.
Yes, sir. Yes, sir.
R12 and C1 is a common element. That's why you have to write the equation two currents, I2 minus I1. So please listen carefully. While you are writing the equation, you should be very, very careful while you are approaching the mesh type problems. Because you have to consider the current direction. If there is a one current or two currents are flowing in the circuit. Okay. So up to this clear? Shall we move on to the force current analogy?
Yes, sir. Sir, till here only answer.
Till one?
Sir, like this is the final answer.
This is the final answer for force voltage analogy. See,
Sir,
you have to derive this equation, two equation. You have to draw this diagram. You have to draw this complete diagram, electrical diagram for the mechanical system. See, only by practice you can get this. Okay, I will give the mechanical translation system. You know the transformation. Mass dash for spring equal to resistance, capacitance, inductance. For force voltage, for force current, what is the difference? Just to connect the element and think that whether this diagram is exactly equal to this one. After drawing this diagram, write the mesh equation. You know how to apply the Kirchhoff law. Then check that how many currents are flowing and verify that whether you consider the both the currents in your equation. If two equations are written correctly, full mark. Okay.
sir, no need of Laplace transformation.
Laplace transformation. This is a
Sir, yesterday you
Laplace transformation later only differential equation. While you are applying the differential equation, after deriving the differential equation, while we apply the Laplace transform, it will be converted into algebraic equation. We are considering only the electrical part, how to get the equivalent circuit from the mechanical system.
Okay, sir.
You can apply Laplace transform also, but usually what we will do in the electrical circuit theory, all the voltage and the current equation in terms of timing only, right?
Yes, sir.
Now, we want to convert it into frequency domain. So the first part, your question is right. In first starting itself, we apply the Laplace transform and convert it into frequency domain. But for electrical system, later we can apply Laplace transform and convert it into frequency domain. But mostly, electrical circuit theory fully deals with the time domain response. Okay.
Okay, sir.
So now up to this force voltage, only the 50% is only completed. Next we have to apply the force current analogy. So force current analogy, what is happening? As already informed, the f of t, you see that the input is current source, I of t. So don't forget that while you are drawing the circuit diagram, whether the input is voltage source or current source, please remember that for force current analogy, you have to replace the voltage source as a current source by putting the arrow mark. Okay, I of t. So the force is converted into I of t. Then next V1 is V1. Velocity V1 is voltage V1. Here reversed. There we convert, there we consider the current I1 and I2. Here the input is V2 is V2. Next again come to the resistance. You see that the dash part is resistance as usual, but it is inversely proportional 1 by R1 and 1 by R2 because of the relation between the voltage and current is reciprocal for the resistance, capacitance, the inductance and the capacitance. So next K1 is inductance, K2 is inductance. For mass it is represented by capacitance. So this difference you have to be understand. That's only I put in the first table. The relation between voltage and current in inductance and capacitance is inversely proportional. So you have to keep in mind that while we are deriving the equation for electrical elements. So whether any doubt in this, the same principle, next you are going to draw the electrical circuit diagram based on force current analogy. So once again, you look out the transformation, whether this transformation, you have any doubt on this transformation. How the mechanical is converted into electrical in force current analogy. Is any doubt in this? Shall we move on next slide?
Yes, sir.
So here for the first one, you see that the first element input side is a current source. So input is a current source. Okay, because it is a force current analogy, input source is a current source. Next, you see that I hope you know that how to do the source conversion. A voltage source with a series resistance can be converted into current source by with a parallel resistor. So this is the basic concept in electrical circuit theory. A voltage source with a series resistance can be converted into current source by connecting a parallel resistor with a current source. So this is the source transformation, how to convert the voltage source into current source. The same thing we are doing here, right? So if the capacitance and resistance are connected in series, you have to connect them in a parallel with the current source. So that's why the C1 and R1 are connected in parallel. So please listen carefully. This is the difference between force voltage and the force current analogy. Next R12 and L1. So this R12 and L1. So this is the system. R12, B12 represents R12 and K represents the L1. So these two elements are connected to the node 1. That's why in force current analogy, R12 and L1 are connected in parallel. Okay, so this is for node 1 side. So next node 2 side, the same two elements R12 and L1 are connected in parallel. And again for force current analogy, we have to connect the resistance capacitance in parallel connection. The C2, R2 and L2 are connected in parallel because we are converting the voltage source into the current source. So based on the node 1 and node 2, you have to write the equation, Kirchhoff equation. So first for node 1, that is for 8-1. So first one C1 into D1t. So first is starting from the I1 of t. So for the node 1, I of t, that is current source is the input. So this is your input side. So next C1 into dV1 by dt. And the second one, it is R1, that is 1 by R1 into V1, voltage drop across the resistance. That is I equal to V by R. That's why it is 1 by R1 into V1 or V1 by R1. And second element is R12. This R12 is a common between first node and the second node. So that's why R12, 1 by R12 into V1 minus V2. That is the current flow through the resistor R12 is V by R, V1 minus V2 divided by R12. So next current flow through the L1 is given by 1 by L1 integral of V1 minus V2 into dt. So you have to draw the circuit for node 1 and write the Kirchhoff current law. You should not miss anyone in the element. You have to consider all the element and write the equation. If any one of the element is missed, suppose you are carelessly missed, the complete equation will be considered as a 0 mark. Okay. So for the second node 2, so since there is no input this side, therefore the input is 0. So input is 0 side. So again, first start from the C2, that is the C2 is a individual element, and then R2, that is the current flowing through the resistor R2, R equal to V by I, therefore this side voltage is V2 by R2. The next inductance L2, current through the inductor L2 is 1 by L2 into integral of V2 into dt. So next coming to the common element, R12 and L1 is common, therefore R12 and then L1 is common element. So this is the 780 equation with the representation for the force current analogy. So if you have any doubt in this, how to represent for force current analogy, it is exactly opposite for the force voltage. So for better understanding, you understand force voltage analogy. Very, very carefully practice the problem for FV, that is force voltage. If you understand very clearly about the force voltage, it is easy to transform into force current. Once you draw the circuit, draw the expression for force voltage correctly, easily you can translate it. Here R means here 1 by R. Here it is a voltage is common means here the current is common. So like that you can easily transform from force voltage to force current. Here 1 by C, here C into dV by dt. So like that once you thorough with the force voltage analogy, you can, from that equation, you just copy and paste that for force current analogy. It is a reverse of that force voltage. Force current is reverse of the force voltage. Still have any doubt in this? Because of only problem we have, the only one example problem we have discussed. The next 2, 3, 4 will be a tutorial problem. Next section will be moving on to block diagram. So kindly please follow the topic, as the time period is very short, because control system usually requires 4 classes per week, but we are taking 3 classes per week. So only if you are cooperating, so don't look out others, what others are saying, what are not saying, don't look out at it. For your self-interest, you have to learn something, you have to gain some knowledge, because you have to do something better than others, right? So don't wait for others. If others are not doing it, you also don't copy from others. You just take the paper and pen and you work out the problem, practice the control system, because this control system not stopping up to this semester. Only if you're strong with the control system, it will be goes on to the next semester. So next analog and digital electronics, and later you have the power electronics subject, and especially in your communication system, I don't know that wireless communication technology, everything it deals with the control system concept. If you have any doubt, please message me personally, or if you want some more workout problems, I will share the slides with you. You go through the problem and practice more problems. Okay. So any doubt in this? Force voltage and force current analogy. So again, I didn't get reply from anyone, but only one guy repeatedly replying. What about others? Sir, next slide.
Yes, sir.
See, still now you understand or not, man? Still now you understand, or I am going very fast? See, be frank, man. Tell everything, because of it is your class. Each and every hour you have to spend the useful time. Okay. I am going very fast, or I have to slow down, or we can move like this way. So after that, you are getting this force current analogous circuit. So this circuit is derived from the previous one. So this part is common. This part is common. So this part is common, R1 to L1 and R1 to L1. This is a common part. So the remaining thing is you have to merge the two circuit. Node 1, you have to derive one circuit. Node 2, derive one circuit and merge the two circuit. So the first one, the node 1 represents the input current source C1 and R1. So this is represented as input current source C1 and R1. And this R12 and L1 is a common. So remaining thing is C2, R2 and L2. C2, R2 and L2. So this is specified here, C2, R2 and L2. So there these elements are connected in series, here you have to connect it in parallel. So that is the difference. Because it is a source conversion, source transformation from voltage source to current source. So up to this force voltage, force current analogy is over. So today I will share the 3 tutorial problems. You have to post that assignment 2 in GCR. Okay. So any doubt in this?
No, sir.
So next class we will start the block diagram reduction. So today I will share the tutorial problems and assignment problems.
Okay.
Okay. See, anything you want to share, man? Still now, you have any problem?
No problem.
No problem. Okay, that means it is a big problem, man. So, okay, shall I wind up? I hope you will see the attendance, right? See, some of them showing exactly the time minutes. See, 43 minutes and 42 minutes. Uh, so this also okay. But see, some of them are 11 minutes. And this guy 1 minute to 3 minutes. See, again, I'm telling you why I'm sharing the screen means if anything happened in the future, attendance problem means
Excuse me, sir.
you are the responsible for that. Okay, because of not for all the students, some of the students are clearly showing it is a 39, 40 minutes, 43. But I don't know, some of them it's not showing the name list.
Sir,
Sir, my name is
most of the names are not there, sir.
See,
Sir.
that's only I am also thinking, man.
Sir, I can see my name.
Only
Sir,
26
it's
names
Yes,
are
sir.
there.
only
Attendance
me.
member, it is showing 38 minutes.
Yes,
So you can take manual attendance, sir. That would be.
it's a better, right?
Yes, sir.
But it's showing
Yes,
56
sir.
students are here. But it's showing
Having
56
the
students are
network
here.
issues, sir. So sir, excuse me, sir.
Yes, tell man.
Sir, I was actually having a network issue, so I was getting disconnected and connecting again. So there it might be having a small problem regarding the attendance.
Hey, today I'll give okay, man. Today I'll give the attendance, man. From next class onwards, we will take the manual attendance, or we can. I will see the alternate way. What other faculties are doing.
Okay, sir, sure.
Okay, man. Okay, today I'll share the. Today I'll share the problem, sir. You will submit the assignment. Okay, next class onwards we starting the block diagram reduction technique. Okay, man. Thank you.
Okay, sir.
Can wind up.
No, thank you.
Thank you.
Thank you, sir.
Sir,
Yes, tell man.
sir, yesterday the which you sent that mesh and current analysis method.
Yes. See, your name is Lokesh.
Yes, sir.
Lokesh. Tell man. See, yesterday I shared that. Have you go through the PPT?
Sir, in that one doubt like is there an
Yes.
example?
What is the doubt? Example 2.
Sir, can you open that PPT?
Which problem,
Mesh
man?
and current. Mesh
Yes,
and current analysis.
Okay. Just a minute. Can you able to see my screen?
No, sir.
So we can leave, sir.
You can leave, man. Leave.
Okay, sir.
See, which one, man? Introduction to network theorems, Okay, sir.
Yes, sir. This one mesh current and method of and analysis. Otherwise, I'll send you a screenshot of that question.
Just a minute. I will open that.
Okay, sir.
See, how many? Mesh current analysis. Mesh current method and analysis, right?
Yes, sir.
Can you able to see the screen?
No, sir. Yes, sir.
See, which
In
slide,
the
man?
last, but third slide. From the last third slide. From the last.
From the last third slide,
Yes, sir. So this question.
Slide, example 2.
Yeah, this question.
Hmm.
Like how to solve this one.
See, already I have given the Messi equation, man. See, first you have to consider there are 3 nodes. First one, E1, E2, E2, E3. There are 3 nodes.
Okay.
Okay.
Sir.
So
Okay.
first you have to consider this loop.
Okay.
So for the first equation, so there are how to say that? This one marker. Okay, there are 3 nodes.
Yes,
So
sir.
this is one thing. Huh?
Okay,
This is
sir.
the second one.
Okay, sir.
And the other node is, this is the third one. There
Okay,
are
sir.
3. So therefore, we are writing the 3 equations. E1, E2 and E3. So the first one, V1 plus V2, that is into E1.
Oh, understood, sir. I'll try it.
You tried this through loops.
No,
One
I'll
to
try it. I'll try, sir.
Come on, actually, that is transformed into equivalent circuit like this.
Not that.
So from the previous one, I am continuing from the previous example one. So this is the right thing. So there are three loops. So first, second, and third loop. For each loop, we have to write this equation. It is G1 plus G2 into E1.
Okay, sir.
So G1 plus G2 is R1 plus R2 because the two currents are dividing.
Yes.
Minus G1 into E2. I look out and I'll try to simplify this problem. Okay, because
sir,
of G is nothing but a conductance.
Yeah, that's why I got like.
Because of we are solving this problem by converting the resistance into conductance, then only we can find out the voltage and the current.
Okay, that's why G like I couldn't.
G represents the conductance. So we are not considering the resistance. The G equal to 1 by R, right?
Okay, sir.
That is reciprocal resistance is conductance. Based on the conductance value, we solved this problem. Then we using the calculator, the simultaneous equation solving, we are getting the values of E1, E2, and E3.
Okay, sir. So like we can't solve with resistance.
Can't solve with?
Resistance, directly taking resistance and.
No, actually, you can solve this problem with the resistance itself. That is the standard method of considering the resistance.
Yes.
Usually, they solve this standard method. But I have approached this problem through conductance method.
Okay, sir.
1 by R, that just 1 by R is the G value.
Okay, sir.
Instead of putting the R directly, we are converting into the conductance. I think I started from this. See, look out, man, from the previous slide. So I have started this problem as a conductance G1 1 by R1, G2 1 by R2.
Yes, sir.
Next converted into the equivalent circuit diagram, alternate circuit diagram. Based on this, it is easy to get the current and voltage value.
Okay, sir. Sir, once I'll read about that, like I don't know.
Man. You go through this. Another important thing is, while we are considering the conductance, it will be different from the resistance. Series connection of resistance and the parallel connection of resistances
will be
exactly reciprocal or reverse.
Yes, yes, sir.
Series and parallel connection of the resistances reversed for conductance.
Yes, sir. Yes, sir. Okay, sir.
Okay, man. You go through problem. I also try to make a simplify in terms of resistance. Okay.
Okay, sir.
Okay.
Thank you, sir.
Thanks. Okay, sir. Thanks for interest.